Hey everybody, I just made up this example to demonstrate conservation of linear momentum. So let's say we have block 1 over here heading toward the right, and this is all on a smooth surface. So block 1 collides with block 2 over here, so there's a collision. And then we're not sure which way block 1 goes, but then block 2 heads over to the right. So then block 2 continues over to the right and collides with block 3. So then there's a second collision, and this time let's assume that they stick together. So this would be a perfectly inelastic collision where they stick together. And then this one is just some inelastic collision. Okay, so what's conserved? For this collision, momentum is conserved. For this collision, momentum is conserved. And we can't really assume energy is conserved anywhere in either collision. Okay, so for collision 1, and let's try and figure out how fast are the two blocks going after that collision. So we're given this velocity here and this velocity here. So before the first collision and after the second collision, and we want to know what went on in between. Okay, so for collision 1, momentum is conserved. So let's just label these just so that, let's call this V1 final. After the collision, let's call this V2 final, which is after the collision. Okay, so for here, conservation of momentum. So before this collision, what was the momentum? This block had momentum, M1, V1 initial I'll call it, which is 9, plus the momentum of this, which is 0 because it's not moving. So that's it. So there's a momentum initial and final. Okay, so after the collision right here, this block has momentum, M1, V1 final I'll call it. This block has momentum, M2, V2 final. Okay, and then that's it. Now, the second collision, immediately before the collision, what's the momentum? Right here. Block 2 has momentum. Okay, so block 2 has momentum, M2, V2 final. I mean, it's weird that this is initial, but then it's just whatever value this was, right, goes here. Okay, so block 2 has momentum before the collision. Block 3, the momentum is 0 because it's not moving, it's at rest. So then that's it. And then after the collision, right here, the mass, M2 plus M3, because they're stuck together, and I'll just call it V final, which is 3. Okay, so what is known and what is unknown? We know this right here, that's 3, or -3, depending on your choice of coordinates, right? So let's say if we pick coordinates this way is positive, then that would be +3. This would be +9. Okay, so we know this value. We know the masses. So the only unknown, this. Okay, now let's go to this equation. We don't know this or this. V1 initial is 9 if this way is positive. Okay, so we have 2 equations, 2 unknowns. So see the method, right? Figure out of all the equations you know, which ones do you use, write them out, and then figure out what's known and what's unknown. When we do that, which equation do you want to solve first? This one, right? So you would solve this one first. V2 final is, oh, this should be an M3 over here. Okay, so M2 plus M3 over M2 times V final. Right, and then just plug in numbers here if you want. So, okay, so that's 6 kilograms and 5 kilograms. So kilograms over kilograms, and then V final was 3. Okay, so that's 11 over 6 times 3, 33 over 6, so that's 5 and 3/6. Okay, so we know the speed. So this is 5.5 meters per second. And now that we know that answer, we can plug that in right there. Right, and then solve for V1 final. V1 final is M1, oh here, minus M2 V2 final, and then just divide everything by M1. And there we go, right? So that's V1 final. Then you can plug in numbers. V1 initial, 9 minus M2 over M1, V2 final, which is all of this technically goes here. It's good if you keep extra decimals so you don't have round off error. Okay, so that's 9 minus 11, so -2. Okay, so actually, so this ended up being negative. So that means block 2 over here is going 5.5 meters per second toward the right, and block 1 is going 2 meters per second to the left. Okay, so I hope that was helpful. Keep on practicing. I'll see you on the next video.